Hi guys, Erin here. This week is all about the experimental research strategy, which is also known as experiments and in the medical world as randomized controlled trials. Here's where this video fits in the context of our course and in the whole research process. In this video, you're going to be learning about what is an experiment, how it differs from non-experiments and quasi-experiments, and what is so special about an experiment that it allows us to overcome the third variable and the directionality problem in order to establish a cause and effect relationship. So over the last few weeks, we've been talking about different research strategies and how they allow us to answer different research questions. We've talked about ways we can describe a variable, describe the relationship between two variables. This week and next week, we'll be talking about experiments, which are all about, or whose goal it is to explain the relationship between two variables. So only with a true experiment do we have the potential to show a cause and effect relationship. Because we can show in this high quality experiment that a change in one variable is directly responsible for causing a change in a second variable. And this search for a cause and effect relationship is really at the heart of the quantitative research method and of the whole scientific process. We might think in real life that it's easy to determine that one thing causes change to another, but in reality, it's really hard to know that it is just that one thing that's causing change in another thing and not something else that's interfering. Only with a true experiment can we do this, because researchers create the different treatment conditions. They randomly assign participants to receive those conditions, and they set enough controls in place to be sure that it's only that one variable that they're interested in that differs between the conditions, and so only that one variable is what could be causing the change in another. It's only in this very highly controlled design that we can determine that change in one thing causes change in another. But this search for a cause and effect relationship is really important. It's what allows us to determine that a medication, a medical treatment, any kind of treatment really is safe and it's effective. This is why it's so important that policy is rooted in science and that you, in your future work with children, that you have an understanding of this as well. So let's talk now more about what experiments are and how they differ from non-experiments and quasi-experiments, and why those differences are so important in determining the kind of conclusions you can draw from the study. I'm going to use an example from education about the relationship between math and music. There's some evidence that kids who play a musical instrument are better at math than kids that don't play a musical instrument. But just observing this relationship, does that mean that music training is what causes the improved math scores? What do you think? Well, we could actually do this kind of design. We could identify two groups of people that exist in the world. So we've got musicians versus non-musicians, and we could look to see if they differ in their math. And this would be an example of a differential research. Or we could compare kids after 1 year of having piano lessons and compare them to kids who didn't get anything in that time period. That would be an example of a post-test only non-equivalent control group design. We could then measure their math scores, look at the average score in our musicians compared to our non-musicians, and maybe we would find that math is higher in the musicians than the non-musicians, and we could describe that relationship, but that's really all we could do. We couldn't say that it's the music that's causing their math to improve. And we can't do this for a number of reasons. First of all, we're not measuring any other variable that could also contribute to their math scores. And we don't, but because we're not measuring it, we don't know if the groups also differ in that as well. So for example, it could be that families that can afford to have their kids in music lessons are also the families that can afford for tutoring or have the education and emotional capacity to be able to sit with their kids every night and do math homework with them. So we call this social economic status, how much money and education is in the home. We're not measuring SES. We're not establishing that the groups are similar in their SES. So we have no way of knowing if the higher math scores in the music group is really due to the music, or if it's due to the SES of the families. So we talked about this last week. We called this the third variable problem. And we said that one solution to this third variable problem would be to control for it. We could measure our SES and we could recruit kids in such a way to ensure that our groups are the same in their SES. And that would allow us to determine at least that SES is not causing their improved math scores. Quasi-experiments do this to some extent, but experiments can do it even better. So this would be what a quasi-experiment would do. We'd again recruit two groups of kids, musicians versus non-musicians. We'd measure the math scores in our two groups and look to see if there's a difference between groups. And we would control for other variables that could provide an alternative explanation for the results. So we would recruit kids in such a way to ensure that there's no difference in their SES, or like we talked about last week, we could also measure their math scores before and after getting music or getting a similar time period where they got nothing, and look to see if our music kids make a greater change than our non-musician kids. We called this a pre-test, post-test, non-equivalent control group design. So a quasi-experiment is better than a non-experiment. In particular, a quasi-experiment is attempting to rule out the third variable problem. However, a challenge with a quasi-experiment is because we're still recruiting groups that exist in the real world, and we're not creating the groups ourselves, we don't know, we can't overcome the chicken or the egg problem, which is also called the directionality problem. So we don't know if kids are better at math because of the music, or if it's that kids who are innately better at math, maybe seeing patterns, are the ones that are drawn to music, and that actually it's the better math that's improving and making it so that they want to take music. Because we're recruiting groups of kids that are pre-selected, that already exist in the world, we really can't overcome the directionality problem with a quasi-experiment. So what we can do is an experiment, and an experiment can overcome both the third variable and the directionality problem because we're also manipulating another variable. So in a true experiment, the experimenter has maximal control over everything. Rather than recruiting groups of participants that already exist in the world, the experimenter is creating the groups. So they're manipulating the independent variable to create two or more groups or conditions. And only in this kind of design, where we're manipulating the variable and we're controlling it, and we see that there's a group difference, can we feel more confident that it's actually due to the music training. So in an experiment, it would look something like this, where we're taking a large group of participants who have agreed to participate in our study. We're creating two conditions. We're creating the music training condition and the nothing condition. And we're manipulating this variable to create these two conditions. We're assigning participants in such a way that we're ensuring that we're controlling for other third variables, that groups are as equivalent as possible on all other variables that could contribute to their math scores. And in such a design, in such an experiment, can we feel more confident that any difference between two groups is really due to our treatment that we're interested in, so that any difference in math is actually due to the music training. So to give you some terminology here, in a true experiment, we're manipulating one variable. We call this the independent variable, to create two or more treatment conditions. So the different conditions are called the levels of the independent variable. In this example, we've got two, but we could have 3 or 4 or 5 groups. That would be 3 or 4 or 5 levels of the independent variable. We're then measuring another variable, our outcome variable. We call this the dependent variable. In all of our participants, we're taking an average in this group compared to this group, and we're looking to see if this group is greater than this group, all the while doing it in such a way that we've controlled for all possible other variables to ensure that those extraneous variables cannot provide an alternative explanation for our results. So in other words, they're not confounding variables. So I know sometimes these terms are tricky, but you can think of it in this way. In a true experiment, we've got an independent variable, so that variable we're interested in, and we've created it in such a way that it's independent from all other things. And then we want to look to see if the scores in our outcome variable depend on which level of the independent variable participants were assigned to. So there's 4 basic elements of an experiment: manipulation, that creation of the different treatment conditions and randomly assigning people to receive the different conditions; measurement, measuring that dependent variable for every individual so that we get 2 groups of scores, comparing those 2 groups using statistics, all the while controlling for other variables so that they can't provide an alternative explanation for the results. So non-experiments have this measurement and comparison piece. Quasi-experiments also have the control piece, but the unique part about an experiment is it also has the manipulation piece. So an experiment always involves some controlled comparison and manipulation. So we're always randomly assigning participants to get our treatment or this one condition we're interested in compared to something else. And that something else, well, we have control over that as well. So in that example that I just gave you, where we're comparing kids that are randomly assigned to get music versus nothing else, this would be an example of a non-treatment control group. Or even better yet, we would randomly assign kids to get our music, our treatment that we're interested in, compared to some other treatment that just doesn't have the active ingredients to what we're interested in. We call this a placebo control group. So in our example, we could randomly assign kids to get either music or to get something that has the look and feel that it's special. So maybe they're still coming into the lab to receive some sort of training, and the schedule of the training and the ratio of teachers to kids are similar. It's just the content is different. So rather than learning music, maybe kids are learning art. And then we measure their math scores in 2 groups. So this would be an even higher quality experiment where our treatment group is receiving something and our control group is receiving something else. So this would ensure that we know that it's the ingredients of the treatment program that is actually what's driving an improved math scores. So this is really important. This is called the placebo effect, and you can learn about it more. I've given a link where David Suzuki, he's so great to listen to, talks more about the placebo effect. In an ideal high quality experiment, we would do what's called a double-blind placebo control group. So in this case, participants are randomly assigned to receive our treatment of interest compared to receiving some sort of something that has the look and feel of the treatment. It's just some of the ingredients are different. And importantly, the experimenter who's analyzing the data doesn't know which individual has been assigned to which condition, and also the participants themselves don't know that whether they're getting the thing that's special or not. This controls for the placebo effect, which is a very powerful effect that can impact the dependent variable just because the participant knows that they've been chosen to participate. Another important thing that a high quality experiment would do is called a manipulation check. This would be to directly measure whether the independent variable has the intended effect on the participant. So in this case, when we're talking about participants receiving music training versus art training, we would actually look to see, did kids learn anything from the music training? Look to see if the manipulation actually worked, if they were actually engaged in the study. This would be really great. And in an ideal world, we would actually look to see, do kids who make the most amount of improvement in music show the most amount of improvement in their math scores. Stay tuned. In future weeks, we're going to be talking about factorial designs, which are all about having multiple variables in the same study and how that can make for a really great quality design. So non-experiments and quasi-experiments in some ways are similar to experiments. We have the same data. We're always comparing either 2 groups Or in some cases, which we'll talk about in future weeks, we're comparing one group as they receive different treatments. The main difference is whether the experimenter is determining who goes into which groups, or if the groups are already pre-selected. As a result of this, these designs have different goals. Only an experiment has the goal of being able to establish a cause and effect relationship and to explain the relationship between two variables. These designs differ also in their benefits and their limitations. Non-experiments and quasi-experiments tend to have high external validity because we're comparing groups of people that already exist in the world, typically in a more real-to-life situation, doing more real-to-life tasks. Higher external validity for non-experiments and quasi-experiments. Whereas on the other hand, experiments, they tend to be conducted in a lab in much more controlled situations so that we're isolating just two variables to see what their relationship is. And as a result, experiments tend to be higher in internal validity. So to summarize, the goal of an experiment is to establish a cause and effect relationship. Two challenges to this are the directionality problem and the third variable problem. To overcome them, experiments have 4 elements where we manipulate the independent variable, we measure the dependent variable, we compare levels of the independent variable in terms of their scores on the dependent variable, all the while controlling for extraneous variables to ensure that they don't provide an alternative explanation for our results. The hallmark feature of an experiment are those manipulation and control pieces. In an experiment, we always do a controlled comparison, which we could compare our treatment group, one level of our independent variable, to a non-treatment or a placebo control group. And in a great quality study, we would also do a manipulation check to make sure that our assigning to the independent variable actually worked. Only experiments can establish a cause and effect relationship because of their high internal validity. So moving forward in your life, you're going to hear lots of sensational findings in the media, wherever, saying that one thing causes change to another. I hope that from now on, your spidey sense is going to go up and you're going to know to look to the original studies, to look to the methods, to look to see how did they actually do the study? Did they do a highly controlled, randomized control trial? Only in this kind of situations can we establish a cause and effect relationship. So I know we covered a lot of ground in this video. A great way to review would be to see if you can match these terms on the left with their definitions on the right. Currently, they're all mixed up. And also see of these 4 elements of an experiment, which are unique to an experiment and which ones do non-experiments and quasi-experiments also have. And if you're interested in whether this one example of medication, cold effects, actually has an effect in improving immunity and decreasing your cold symptoms, check out the link. I've got a link to the study so you can read it for yourself. Thanks so much for listening, and we'll see you at the next video.